In today's video, we're going to look at some solutions from Friday's assignment. And what they want us to do is to find the product or quotient. And just a quick review, the product is the answer to a multiplication problem, such as number one. When you have things in parentheses and they're next to each other, that means we're multiplying. And the quotient means the answer to a division problem, such as number seven. When you have a fraction bar, that means we're dividing. And then they also want us to write our answer in scientific notation. I'm going to do a couple of the multiplication problems and a couple of the division problems. Let's go and begin by looking at number one. So when you're multiplying scientific notation, the first thing you want to do is rewrite your problem by using the commutative property. And what the commutative property tells you is that order doesn't matter when you're multiplying. So what I'm doing is I'm going to take my numbers and put those together, and I'm going to take my powers and put them together. So my problem now is going to look like 2.3 times 3 and 10 to the fourth times 10 to the eighth. So I just took my numbers and put them together, and I took my powers and put them together. Basically what I did is I created two different problems. I have a multiplication of numbers and a multiplication of powers. So I'm going to begin by doing the numbers. 3 times 2.3 gives me 6.9. I then brought down my 10 to the fourth times 10 to the eighth. And then when you have 10 to the fourth times 10 to the eighth, you should be reminded of the product rule. And what the product rule tells you is that when you have the same base and you're multiplying, you're going to add the exponents. And 4 plus 8 gives me 10 to the 12th. You could have parentheses around your final answer if you want, but you don't need them. And then before you box your answer, you're going to ask yourself a question. Is your answer in scientific notation? In other words, is the number in front between 1 and 10? In this case, yes, 6.9 is between 1 and 10. So I can go and box our final answer, and we're done with number 1. Let's look at number 3 next. Same idea. I'm going to use the commutative property. I'm going to put my numbers together, and I'm going to put my powers together. When I do the numbers, 7.25 times 2.4 gives me 17.4. And when I do 10 to the third times 10 to the negative 5, I add the exponents, and 3 plus negative 5 gives me the negative 2. I'm now going to ask myself a question. Is my answer in scientific notation? Well, no. The number in the front is 17.4. That's not between 1 and 10. That's bigger than 10. So I need to make this number between 1 and 10. So I need to move that decimal place one spot to the left. 17.4 becomes 1.74. But we have to remember, if one side goes down, the other side has to go up. So we add 1 to the negative 2, and it becomes negative 1. So our final answer is 1.74 times 10 to the negative first power. Finally, let's look at number 6. Number 6 is 2.5 times 10 to the fifth, all squared. So remind yourself, what does squared mean? That means something times itself. In other words, we're doing 2.5 times 10 to the fifth multiplied by itself. So we have 2.5 times 10 to the fifth 2 times. That's what the second power means. And now it looks just like the previous problems. I'm going to take my numbers and put them together. And I'm going to take my powers and put them together. 2.5 times 2.5 is 6.25. And 10 to the fifth times 10 to the fifth, I add the exponents. 5 plus 5 gives me 10. Once again, is your answer in scientific notation? Yes, 6.25 is between 1 and 10. So I can box my answer, and we're all done with the multiplication problems I want to look at. Now let's look at some of the division problems. Let's start with number 7. Same idea as the multiplication. You're going to break it up into 2 different problems. You're going to begin by looking at the numbers. And this is pretty easy. 8 divided by 2, well, that gives me 4. You're then going to bring down your multiplication sign. And now we're going to take care of the other problem. We're going to look at the powers. 10 to the fourth divided by 10 to the second power. Well, now you're going to be using the quotient rule. And what the quotient rule says is that when you have the same base and you're dividing, you're going to subtract the exponents. And 4 take away 2 gives me to the second power. And then once again, ask yourself the question, is my answer in scientific notation? Yes, 4 is between 1 and 10. So we can box an answer, and we're all done with number 7. Let's look at number 9 next. Same idea. I'm going to start by focusing on the numbers. 2.6565 divided by 2.1 will give you 1.265. And then now let's look at the powers. 10 to the 6th divided by 10 to the negative 1. That means you're going to subtract. 6 take away a negative 1. That's the same thing as 6 plus 1. So if you do the math correctly, you get times 10 to the 7th. Is my answer in scientific notation? Yes, the number in front is between 1 and 10. So we can box that answer, and we're all done with number 9. And finally, let's look at number 12. If you don't like the problem written this way, you can write it similar to the last problems. You can write it as a fraction. Remember this division sign, that's the same thing as a fraction. And you're going to notice that the 8.5 is missing a power of 10. If it doesn't have a power of 10, what that means is that it's raised to the 0 power. So this is 8.5 times 10 to the 0 all over 3.5 times 10 to the 9th. So this step is optional. You don't need to do this unless you want to. For many of you, it's going to be a little more comfortable. And then once again, I'm going to do the same steps. I'm going to divide the numbers. 8.5 divided by 3.5 is 2.42 and all this other nonsense times 10 to the negative 9. The reason I got negative 9 is I did 0 take away 9. And 0 take away 9 will give you negative 9. And once again, is this answer in sign notation? Yes, it is. So you can box that, and we're all done with number 12.